Hello, my name is Andren. Today I'm going to make an experiment to apply the conservation of energy and show you how to solve the coefficient of restitution, which will determine whether the ball will rebound or not. So first of all, we need a couple of equations to solve the problem. As you can see in the camera there are two equations that we have. The first one is the coefficient of restitution equation. Is this one right here, E equal to the relative speed after collision over the relative speed before the collision. And as you can see, the value of coefficient of restitution is very important. If it equal to 0, it means the ball will not rebound. If equal to 1, it means it will rebound to the original position, meaning that no kinetic energy lost. And so if it's between 1 and 0, it means some kinetic energy has been lost or converted to other forms such as heat or deformation. The second equation is the conservation of energy equation. The kinetic energy before the collision plus the potential energy before collision equal to sum of the kinetic energy after the collision. And so after that, you just solve for it, and I got that after I factor out the mass. Okay, and so now I'm going to make an experiment, and I'll come back and show you how to use the data to find out the coefficient of restitution and apply the conservation of energy principle to find out all of these. Okay. Hello, this is my experiment part. I'll do 3 trials. First, I'm going to set the ruler at 59 inches. The second trial, the first one is 49 inches, the second one is 59 inches, and the third one is 29 inches. So let's start. Now I'm setting the ruler at 49 inches. I'm going to drop it 1, 2, 3. Okay, so the first rebound of 49 inches is 16 inches when it rebounds, as I saw. The second one, 59 inches. I'm going to drop it 1, 2, 3. So when it rebounds, the first rebound is at 20 inch. The third trial is at 29 inches. One, two, 3. The first rebound was at 16 inch. And that's pretty much it for my experiment. Hello, I'm back. So now I'm going to solve the problems from the data collected. First of all, I'm going to divide the problems into 2 phases. One of those phases is that the first phase is I'm going to find the velocity. I'm going to apply the conservation of energy to find the velocity of the ball before and after the collision. Then the second phase is I'm going to use those velocity to determine the coefficient of restitution. So this is the equation that I showed you before the experiment. Is this the conservation of energy principle equation? So I just used one of the data that I collected. The 59 inches equal to 1.5 meters, and the height is equal to 0. And therefore, now just plug into this equation that I got from before. So now, because right here I cancel out, I put this and this equal to 0. First of all, this equal to 0 because the velocity right here is when I'm holding the ball. The velocity is not moving, therefore it equal to 0. And there's a moment when I'm still holding the ball. And right here is when the ball almost hit the ground, like when it almost touch the ground, when it almost touches the ground right here. But it has not hit the ground really hard yet. So right here the height is supposed to be 0. Therefore, after I solve everything, 0 times the gravity is it should be 0. And so now the height here and the velocity here, I just plug in the equation. The height here is when I'm holding the ball is 59 inches, which is equivalent to 1.50 meters. So I just plug it in there. And 1/2 times velocity when the ball almost hit the ground or when it's moving, and more specifically when I already release the ball. So right there, the velocity is the one that we have to find, which is not given. We have to find through calculation by solving this equation, and there I got 5.42 meters per second. And this whole process is when this happens when the ball before the ball hit the ground. So so now I'm going to solve the velocity after the ball hit the ground, because right here the equation of coefficient of restitution requires the velocity after the collision over the velocity before the collision. So now the same process as the one that we solved before. I just use the same equation of conservation of energy, and I use the data that I got, h2 equal to 20 inches, which is when the ball from the ground it moves up to maximum height. Right there, the maximum height that it got is 20 inches. The first bound. This is for the first bound, not for the second bound. Okay, and there the camera is kind of blurry. Okay, there is equivalent to 0.508 meters. And so I just again I cancel this out. I just put them equal to 0 because the height right here when it from the ground is moving up, but right here is still moving, but I just use I just count from here is when the ball height is 0. And so when it's moved up to maximum height right there, the ball stops moving when it reaches the maximum height, and therefore the velocity equal to 0 as well. So I just put them equal to 0. And also after I solve those, I cancel them out and I just plug in the equation there. And now, as you can see, the velocity when it's moving from here to maximum height, we don't know yet, so we have to find it by plugging in the equation. And there I got the result. After all, we just plug in the relative speed after collision over the relative speed before collision. And as you can see, this is after collision, and this is the V1, which is when the ball is right here, when it's started to moving up. And right here is the position when the ball has touched the ground, and right here is when I'm holding the ball. Okay, so there I got the coefficient of restitution value, and the other trials is exactly the same. You can solve it again. Doing this experiment is pretty fun. Okay, and that's pretty much it. So thank you for watching, and if you have questions, please put the comments below.